share now. Okay. So you got that beautiful thing for everything. What is subject oriented, time variant, everything. So next is like why data warehouse. See, data warehouse is like your SQL only, like you have rows, columns, everything. So very consistent data, acid property. That's what you have to look into the acid. Atomicity, consistency, durability. You will not have a wrong data, junk data. So perfect data. You will have historic data. See, always data warehouse keeps history data. This is one of the point you have to remember. History data means the old data, like yeah, 5 years, 10-year data. That means like if you are right now engineering, it might would have kept from your first standard, LKG, all this information till current date. That is a history data. But OLTP does not keep. Yesterday I told you OLTP and OLAP. OLTP is online transaction processing, where it is used to run the business. For example, you go to the ATM machine, it has to get the data in 5 seconds. You can't wait more than 1 minute also in the ATM. That means they don't keep the huge volume of data. They just keep 3-4 days data. Okay. Or yeah, some months data, however they have done. But the old data is always kept in the data warehouse. And data warehouse is for analyze and report information. Okay, so that is what you have to know. And finally, whatever we do ETL today also, with big data also, at the end they do analyze and report information. Okay, that is done by data scientist or Power BI or Tableau developer. So they are called as reporting folks or analysts. Okay, so why is BI so important? See, today I think right now you have a knowledge. When I was telling them 5-6 years back, students were not able to grasp it, the amount of the value of data. Today, you know, everyone does the analysis with the data, customer analysis. How many people are there in Amazon? How many people have brought that product? So I can do what kind of marketing I have to do for a particular customer. All these things they will do. BI means reporting, business intelligence. Business intelligence means, yeah, business intelligence comes into both the thing. Means data warehouse plus reporting becomes business intelligence. So know all those terms, because as soon as you go to the company, they start BI, your head will be like spinning. So data warehouse plus reports. Reports are like whatever, Power BI, Tableau. Okay, so this were traditional. Now lot of things are there, not only these two things, there are lot of things today. Okay, so I can, yeah, it is very important. Actually the value of this has become grown over the years. At the beginning, like 7-8 years, very few companies were doing this, maybe Walmart or very big organization. Now even a small company, a company which has 50 people, also needs this. Forecasting means the future, prediction of the future, how my sales can go. That's why all these machine learning models, everything have come. Information maturity model, so don't worry about this. Return on information, what happened, all this it will give the answer. What happened to your business? Means if the sales is very down, what happened? Why it happened? What will happen in the future? How it will happen? Which products will get sale in the December? So all this information you will be able to gain from this. That's why they have given here predictive modeling and all are data science concepts. Okay, OLAP is online analytical processing, data warehouse, OLAP, query reporting. Okay, see, reporting was there till what? Now also reporting is there. Data science has just come 3-4 years only. Even the data engineer has come 3-4 years. So why this has come? Because this data science can predict the future by using all this modeling, predictive modeling. What does report can say is, report can just say not the future, current information, like right now what is your marks, or previously what was your marks, that can tell. But descriptive modeling can tell based on your engineering and your old history whether you will become succeeded in life, you will get a good career and all. That's why data science today people are going, because reporting just says the current and old information, history information. But Modeling as the capacity to predict, as the name itself suggests, predictive modeling. It can predict the future. Okay, forecasting, predicting, all those things. Maybe small things we were able to do with reporting, but not a exact predicting and all these things. But today we can do. Okay, BI solution. Actually, it is more of analytical. This PPT is more of analytical than our data warehouse thing. It's more on reporting. So it's okay. So forecasting, modeling, performance, just you get more information. So after we do data warehouse, the ETL pipeline, after doing filter, everything, the transformation goes to the data warehouse. After that, they do all these things, standard reporting. I don't want to go too much on slicing, dicing and all. So BI framework, yeah, all these are BI. Actually ours is mainly on data warehouse, knowing, because we do cleansing, integration, stores and all. After data warehouse, BI reporting. Okay, actually yeah, it's a reverse. Business requirements, BI architecture will contain data warehouse plus reporting. Data warehouse is here, and after data warehouse there is a reporting. Somewhere there should be a business value and there should be a reporting. So they have done. So actually these and all are not required. I don't want you to confuse. All these are part of BI. BI means reporting. After data warehouse, the data goes to the reports, like reports like you have seen. So data warehouse is what we usually concentrate. Data warehouse, ETL process. Even now we do ETL, but we do using Spark. Previously they were using not only Informatica, there were 7-8 tools which I have worked, like Informatica, SAP BODS, Pentavo. All those are the traditional ETL tools where it can take the structured data, it can do all the, can you see here, staging is there. Okay, they call it as ODS, operational data store. So I don't want to go too much into that, then it becomes a complete data warehouse course. So it will become too much for you. Just know the high level. Like data warehouse usually was able to take the structured data. See, that's why everything is database. Hardly some flat file. Flat file means your CSV Excel file. It can import. This is a staging area where cleansing everything will happen, and from here you have that data warehouse. And data mart is again a particular subject data. That's all. Sales, HR, finance, in a company, all these things will be there. And after that, see here, reporting will happen. Reports, how many customers came, how much revenue came, how many sales happened, how many clicks happened. Okay, and after this you will get data science, like modeling, what will be the future sales. Getting that right, that information. See, this is our reporting will be there. There are almost 50-60 kind of graphs, like this is some graph, line graph. There are bar charts, pie charts, Perota chart, so many things are there. Okay, so you get all these things. See, as a business owner, as a CEO of the company, he is very interested in just seeing the reports. You just see the bar graph, he sees, okay, so much revenue. You will see over the year, okay, last year this much was there, this year this much. It comes with the same color, green. Okay, this year the sales has reduced. Why? So that is how they do the business value, business understanding. Okay, KPI, again it's a reporting, key performance indicator. KPIs are nothing but like this one. What are the year to sales, month to sales, what is your cost, how much revenue happened. The same thing are called as key performance indicator. Okay, so these are more into the reporting people. Just I am running through the PPT. I am just trying to cover. So just it will help you with some keywords. Reporting, and I don't want to go very depth into this. Whichever I feel like I can say, I will say. So see, OLTP uses data warehouse. This is important. There can be questions. Okay, so I get this question, direct question. What is the difference between OLTP versus data warehouse? Already I have told, any application at the beginning as a front end and back end. Back end is called OLTP, online transaction processing, which you guys used to run business. But slowly what happened? Huge volume of data came. The data was stored into data warehouse. Like your old things you place in warehouse, right? The same way, data was also kept in, old data for storage purpose was kept in data warehouse. Also, if you have storage purpose, the large volume of data, you can do analysis of the data. That's what. Update a regular basis, ETL process. Again, I think like denormalized. It's all DBMS concept. I don't want to go with that. So this can be the question. They will ask you what do you mean by normalization and denormalization. Very important interview question. So I don't want to go into that. You make a note of that difference between normalized, denormalized form. Just discuss with your SQL trainer, because this is somewhere I have seen a common interview question. What is the difference between OLTP? Actually, the question will extend now further. What the further question will extend? The difference between OLTP, data warehouse, and now we are learning data lake also. Data lake. Tell me the difference. Three questions. Difference between OLTP versus data warehouse versus data lake. Okay. So yeah, now we are covering this. In this, very important point is normalized, denormalized. As soon as you say that, they will ask, can you tell me about normalization? Can you tell me about denormalization? You have 1NF, 2NF, 3NF in normalized. Just know that. In denormalized, you will not have that. And for data warehouse, denormalized is very important. Okay, just know that it's your SQL concept. You can just discuss with your trainer and get more information, because if I start doing it, will only take 45 minutes. If I simply say, you will not understand. There is no point on discussing. Okay, retrieve the, see, only the current information will get the total sales, not only last month, last year, over the year, all those things. So again, fewer index, many index, fewer joins. Why fewer joins? Because of denormalized. Denormalized means all the data in a less table or a single table. Normalized means more number of joins, more tables, many joins. That's why. See, normalized data, less duplicate. Denormalized data, more duplicate. See, very important. You know this. You with this only you can cover 4-5 parts. Where it is going here, it's auto going. So okay. I can also run like this. Typical reporting environment, OLTP, data warehouse. Yeah, same thing. It's going on again and again. OLTP definition, already I have given a generic information. So yeah, generic information is the way. Okay, no one will ask you to mug up gut. Just analytical processing. It's used for analyzing. It stores denormalized data. The data, 4 things you have to tell. OLAP, subject oriented, time variant, and non-volatile, and one more thing was there. Just explain that elaborately. Okay, so OLAP tool, all these things I don't want to say. There are 2 types of approach. Okay, ETL, extract, transform, and load. That is what we will be doing again. So a PLSQL based staging again. Okay, PLSQL you don't need. There is one more architecture whenever you are coming to the data warehouse, star and snowflake architecture. See, star will have what? It resembles the star. See here, there is a single fact table. Again, okay, again I need to say about fact and dimension table. Okay, it becomes slightly complicated. Okay, alright, so I can give you that high level. See, in data warehouse, the common 2 type of architecture we build is star schema, snowflake schema. What do you mean by star schema? It resembles the star. In the middle there will be a fact table. I'll tell you what is fact. Okay, and outside there will be a dimension table. That becomes a star. It resembles the star. You have 2 kind of table, dimension and fact table. And again, it's important even in big data, because even in Redshift I am doing all these things. Star schema, it's all this one, designing, modeling. They call this as modeling. There are modelers who do this. Okay, but yeah, you should know this. This is a snowflake schema. What do you mean by snowflake schema? Here also you have middle fact table, outer dimension table, but dimension table are divided, subdivided. Means it has subdimension table. That means, let me just open the notepad. All these are interesting, but yeah, if I was doing only this course of data warehouse or something, I would have elaborated, but yeah, I'm sorry. So you need to understand at least on the high level, and just let me know, like if you are trying to learn and you really need help, I can help you. Okay, so in data warehouse there are two ways of modeling. We call this as modeling. Like Erwin model is there. Erwin model is mainly for OLTP thing. But for our data warehouse, we follow two kind of modeling: the star schema modeling, and snowflake schema modeling. So star means you have middle fact table. I will tell you what is fact table. Outer dimension table. Both are table only. We call it as fact because it always contains measurable data. Fact means measurable. Measurable data means you will have quantity, revenue, revenue, height, weight. All these are some measurable data. Numbers. Quantity is number, like 100 kg quantity. Revenue like 50 lakh. Height, weight. All these are measurable. So fact usually contain measurable data. One is this kind of information, and one more is foreign key. You should already know primary key and foreign key. In dimension you will have primary key. Okay, ID, like you will have here sales ID, here also sales ID will be there. Maybe here you have sales ID. Here also this would be foreign key, and the same sales ID will be here. That is a primary key. I hope by this time you know the primary key, foreign key. I had only done you taking library college example of primary key, foreign key. Okay, so what will happen is there will be always a connection between dimension and fact table. If you see the figures here, how this connection happens, because of, if it is a product, can you see here product ID? If it is a customer ID. Okay, like that. Maybe there might be promotion ID, channel ID, all those things can be there. Okay, so and apart from this, it also contains the measure, like as I told here, there will be product quantity, product revenue. All those information will contain product. What does dimension, this outer things will contain? If you can only see, can you see the customer last name, customer city? These are not measurable. These are not the fact data. Fact data means it's measurable. You can measure kg, you can measure revenue, but you can't measure the city name, you can't measure the customer first name, last name. All these are descriptive data, not quantity data, quantifiable data, description only. Like, yeah, same thing. Dimension table means you will have, what to say, yeah, product name, customer name, city, only feel, color, like that. Not measurable. You can see by this only. So this is what fact and dimension table contains. Star schema will have a single fact table and outer dimension table, but snowflake schema are further divided. Maybe they have more information. The product has again divided into suppliers. This becomes snowflake schema. Always for our data warehouse, star schema is good. Again, it will change based on the project scenario. When you have a lot of information you want to subdivide. Why? Because again it comes to the concept of normalization, denormalization. Normalization means breaking a single bigger table into smaller table, which is good for OLTP system, not for a data warehouse system, not for OLAP system. But for our data warehouse, always it is good to be denormalized table. Denormalized table means all product data in single table, all customer in single table, channel in single table, promotion in single table. If you divide this table, it becomes normalized, like 1NF, 2NF. You know that. I don't know whether you know or not. So normalized is not good for data warehouse. Normalized is good for OLTP system. Okay, so this is how the things happen. Lot of information. I think this is the maximum I can give. With this time I can't give more than this information. The fun is there are different type of fact tables also. There are different type of dimension table also. I can't go so much deep. Then I told, right, it becomes a data warehouse course, not the big data course. So today's date is 10. Okay, data warehouse class 10 December 23. Okay, so now let us go further. This much you revisit my recording, so if you have this much idea, it's good. But yeah, so obviously, like interviewer, if you are very good in learning all those things, it's always good. Like the more you learn, the interviewer will be happy, because sometimes they ask, what are the things you know? Do you know data warehouse? Good, let me ask data warehouse question. Do you know big data? Let me ask big data question. So means at least theoretical data warehouse, no one will ask you to build something and all. They ask you like logic, connection, primary key. So what happens is, for whatever I am telling is good for your understanding, but in interview they might go very deep. Very deep means, you know, like how the things will happen. I have to teach you deeply. You should also learn 5 times deeply. Okay, so so okay, all right. So what will happen is, like, I am trying to cover more things for you, just so that you have an idea. There is data warehouse also, big data is also there. In the interview, someone asks some question on data warehouse, you will come to know, sir, I had done data warehouse. Let me revisit. Let me go learn this information. Okay, he asked in the interview different type of fact table. Okay, sir did not do, but see, already it came kinds of fact table. Let me go inside and try to tell, because what is the thing is, like, yeah, as you, they will ask only big data, all those things. But yeah, it's good to know. That's what I believe, because yeah, I am thinking in an architect perspective. That is my problem. If I was a developer and teaching you, I would have not exposed you to so much. But yeah, I'm just telling you, like, these are the things are there. Okay, these are like extra syllabus for you, out of syllabus for you for this course, not out of syllabus in the interview or even in the working. Okay, and maybe you will not be working. To do all these things, there will be a modeler, data modelers, they do that, or an architect like us, we do all these things. We should be knowing everything. Okay, that's the problem. Every time we go to the project, we feel we don't know anything, but we have to learn new things and just become keep on working. Okay, see, if you go more into the, say, I don't want to go different type of dimension, degenerated and all, but you know, there is a primary key, foreign key. This is a star schema, middle fact table. See here, what I told, revenue, cost, sold, profit, all these are the foreign key. You will have here primary key and descriptive data. Okay, okay. So yeah, factless, fact table and all. Okay. Surrogate keys are there. Surrogate keys are nothing but a primary key. Usually in our data warehouse, we call it as surrogate key. Okay, so I don't want to speak about all these things. Basic load plan of dimension, time dimension. SCDs. SCDs are important. I'll just give you eye level. I can't teach you how to build it. Okay, so this is a part of data warehousing course. But yeah, I can give you the idea. See, slowly changing, because this is again very important concept in the data warehouse. Slowly changing dimension. We call it as slowly changing dimensions. DIMENSIONS. Okay, we call it as SCD. There are 3 types of famous SCD. SCD1, SCD2, SCD3. Usually SCD2 is most commonly used because it maintains most commonly used as it maintains the history information. For example, it will keep all, if you are studying right now BTech, it will keep all your history from current BTech, means it will keep all the history from your first standard or LKG till BTech. All information is kept, means entire history of your education curriculum, it keeps SCD2. That's why most of the projects goes with SCD2, because it keeps all the information. Okay, it maintains the history, HSTORY, history information, all the information, all the education information, all the education information it keeps. Okay, so SCD1 keeps what information? Only the latest information, only the latest or current information. Current information, if you are studying now BTech, it just keeps BTech information. Maybe some projects don't want the old data, they want only the current data they want to analyze. They try to keep that data in the data warehouse. SCD3, current and previous to current. Current and previous to current. What is current? You are studying BTech. Previous to current is maybe you were studying 12th. That information only it keeps. So most commonly we do SCD2, and there are like some logics to do and all, so which is not required, because it's a pure SCD2 is a pure data warehouse architecture. Okay, but know this, slowly changing dimension, that's what they are telling here. Type 1, type 2, type 3, here history maintaining. Okay, so they have given some way, but whatever I have given, just read that. So they have told technically how to do all these things. SCD1, how you will build that. SCD2, how you will build that. All the architectures. Okay, SCD3, loading a table. So this, as more technical information, this slides, it will also help you. Other slides on data warehouse had more of theoretical information. So I can't go more into technical, then it is again a 50-hour course. This data warehouse is only 50-hour course. Okay, alright, so this is what this PPT. What are the other PPT? Did I downloaded all data? All. So, okay, data warehouse, what are the other things? So I have data warehouse, okay, I have everything here. Okay, so okay, this one also we have not done. Data warehouse, I think, have we done this? Same thing. See, I am running more slides so you get more confident and different way of explaining. See, as soon as data warehouse comes, these 4 things you have to think: subject oriented, integrated, time varied, non-volatile. You already have that information. There is nothing to mug up. It keeps a different subject like finance, audit, marketing, everything integrated from the source. Different database comes, it integrates. Time variant, it keeps the history data like 5-10 years. Non-volatile, it immediately doesn't get it. Means it both almost same, like it will have for a long time the data. Same thing they have more elaborately told. You can read and understand. Okay, so this and all, same thing. How, what is the endpoint? Report, you see the reports. Okay, structured and see, most of the things all are structured data. That still to be this is some other unstructured. Here you don't see any unstructured, semi-structured data. That's the drawback of directly using data warehouse. Stock profile in order to implement. So OLTPs here, these are the things which I want you to be good. That's all. OLTP, OLAP, data warehouse, data mart, SCDs. Okay, see OLTP, OLAP. How you see from here data warehouse, it goes to the reporting. Benefits of OLTP, drawbacks of OLTP, requires instant. This is OLTP versus OLAP. Requires instant update to perform simple even with normalized. See, can you see normalized? As soon as OLTP comes, it's a normalized data. Normalized means more number of tables. For customer only, you will have 5 tables. They do join. That's how the normalized happens. That has its own benefit. Okay. Hence the data we must have a see. That's what they are telling at the beginning. They were trying to do all the reporting also from the OLTP, but there were drawbacks of doing everything in OLTP. Customers were using, even you were pulling the reports, the system was becoming very slow, and because of that there were a lot of issue. That is the reason why we came into the data warehouse. That's all they are telling. So you read it, you will understand that better. So they have some architecture for the data warehouse, the same thing. And what we do extract, load, transform, and it directly not data warehouse. First they put to staging. Yesterday I told, like, there will be a cleansing, that this and all. After that they do integration from different system, they cleanse and move to data mart. Is a single subject area like finance and all, and from data mart there is a data warehouse. Okay, there are a lot of things, but yeah, I can't go ahead and speak. Then I told, right, again 40-50 hours course. So I'm trying to highlight on important thing. I don't want you to be numb in the interview. Someone asks, tell me about OLTP, OLAP, what is this? There are two things. One is, maybe in interview they will ask, even if they don't ask, as a data engineer you should know all these things. Then it's like, you are a dummy. Okay, doing some code will not make you it's like you know how to put a cement and how to put a brick, then you will be only laborer. You can't grow to contractor, engineer and all. So I'm looking you in that direction. Okay, so that's how even the company people like you. And these are theory thing, these are not practical thing where you have to sit and do. These are, you have to study and understand. Okay, you have to do that, study and understand, study and understand, that's all. Okay, data warehouse, because I am also doing the same thing. I also do every day. I have a job, still I am doing. You don't have a job, you have to do it. Okay, so yeah, too much complex, keep it off, simple. This is beautiful. Like, you have source, data warehouse. From data warehouse also they do data mart, or from first data mart, data warehouse. Okay, that is top down bottom up approach. Okay, see your star schema, you have a beautiful picture. This gives you more understanding. Like time, see, usually time will be common in all, because without a time there is no fun, there is no point. When the product came, what is the duration? So product, item, location. See, can you see here, all these are a fact, measurable item, unit sold, dollar sold, average sold. Here you don't see those, only descriptive data, street, city, brand, branch name, all those things. Snowflake scheme, that is what they have explained here. So architecture and all, you can see same thing will be there. Okay, so I think almost data warehouse also I covered. Okay, new PPTs are arising, let us see. I'm also seeing with you only this PPTs. So read, I will share all these PPT, types of data warehouse, data marts. See, this is what I want you to understand. The first PPT we ran was very technical, so I can't explain you or justify that, because it requires lot of showing you practically that architecture. And my intention is also not that. My intention is something like you learn what is data warehouse, what is data mart, and benefits of data warehouse, disadvantages of data warehouse. If you see the disadvantage here, it's usually maintenance cost is high. Can you see here? Actually it's a static, I don't know, it's not static they have given. Okay, maintenance cost is very high, because you have to build structure, everything. It takes 5, I told, right, one project took 2 years. That if with the big data I can do in 3 months. Okay, can get outdated related, see, it becomes outdated. Line data warehouse, duplicate, expensive, functionality may be developed, lot of functions I have to develop, and it in the database if I run, it will take lot of time, because your data warehouse doesn't run parallelly like Spark. That's what I told. Spark is a massively parallel processing engine. Like one task can be given to thousands of people like that. But data warehouse and all, one task can be given to 4-5 people. There is also multiple threading in data warehouse, but it has its limitations. So it becomes very slow, and huge volume of data impossible. Forget about GB data it can do, maximum TB data it can do. TB data was only my data warehouse was blasting. When 7 years, 8 years back, I was working on data warehouse. So for in big data, forget about TBs. Now like petabytes of data can run in an hour or half an hour, like that. If I increase my parallel processing engine, it can run quickly. That is what main thing. So BI, same thing, spreadsheet, that this way of building a report. Data mining comes to your data science. I don't want to go into that. See here everywhere OLAP, OLTP differences, know this. Again, can you see here data warehouse schema, two types of schema, star schema, snowflake schema. Same thing they would have given. You get multiple examples if I give you this 4-5 PPT. So understanding would be very easy. Seeing one example will not understand. You will understand by seeing one more example. And it's advisable you read all these things and try to understand in a eye level. Okay, where in an interview you should be able to know to some extent even while working. Someone asks about, let us build an architecture of snowflake schema in AWS Redshift. What do you say if they ask you? What you will say? If you don't know what is star schema, snowflake schema, so you are gone. That is how it will be there. Whatever you technically learn, if they start asking you those questions, maybe as a fresher 1-2 year they don't ask, but yeah, that is what it happens. So see, all this comes under modeling. Okay, fact table, steps in designing fact table, types of, so see under fact also there are different types. I don't want to delve into that. Same thing, dimension, measures, cubes and all, I don't want to speak. Okay, I think yeah, this as good general information which I was expecting. I think this we covered yesterday. I remember this was covered. Did I cover completely, or in the midway I stopped this? Success and future of data warehouse. See, seeing this, I feel like you are able to understand better, because yeah, okay, bottom up. See, there was something like first data mart, first data warehouse, after that data mart, and I also showed first data marts, after that data marts. They call it as one is top down, one is bottom up. They also call it as some Bill Ilmon, some person invented this. They call that, there is some you see which company first built data warehouse and later data marts. When I know the entire business, one of the company I was working was an insurance company. They were with insurance from 60 years. They know each and every small information. They build data warehouse first, because building data warehouse means all the subject, finance, marketing, different kind of insurance, like health insurance, non-life vehicle insurance, car insurance. They also had pet insurance, marine insurance, plane insurance. They know every kind of subject. So first they build data warehouse. Building data warehouse is very costly compared to data mart. What does data mart keeps? Only a single subject area. When you don't know the business, you are new to the business, what you do, you get some data from the application, you build only data mart, and you keep particular subject area. Only I know finance now, let me build finance. Next, marketing. After that I came to know new product, some loan product. In that, the different kind of loan product, and later you merge all the data and put into data warehouse. Usually when you don't know about your business, a new company, they first build data warehouse, sorry, data marts, and then data warehouse. When you already know business, 100 out of 100 or 100 out of 90, you go ahead with building data warehouse. However, data warehouse building as costly in that. Okay, all right. So this is what top down and bottom up approach. Okay, I think that's it on the data warehouse. So many I covered, big data I had covered. Let us move to the Spark. I know Spark will have little bit of complex thing, but still, yeah. So we will go to the Spark. Before that, I had one more thing, big data on AWS. Okay, so big data on AWS, which we have to learn, but yeah, let me just go through that PPTs, because doing practical is one thing, but without you guys knowing. Okay, did it not download it? Download. Download. Okay, download blocked. Hello, done. Okay, download. Okay, open. So, big data on AWS. This is what we are interested. See, some of the tech meets and all I will be attending. That's where I get PPTs and all. Okay, so yeah, now I am not finding so much time. But still, yeah, it's fine. I have many PPTs. I had lot of PPTs. Some I had filtered because it was not making any sense. I can't dump all PPT on you. Here only like I wanted to merge and remove due to the less amount of time I couldn't do all those things. Maybe in coming batches or something I will do it. But yeah, it's okay. So we will be learning big data mainly on AWS. So obviously I don't think so you'll understand everything because as the AWS comes, it is a services. What is services and all we will learn when I start this. So they have given this is big data, this is MapReduce, this is distributed file system. MapReduce, yesterday I taught you what is MapReduce and distributed file system. As soon as big data comes, it's distributed. It's a parallel engine, not a single thing happening. One data is broken into separate pieces. We saw yesterday map, split, after that reduce, merge, how it happens. That is the underlying concept of big data. Before that, single data, single engine was processing. Now single data goes to a multiple engine process and comes back. This is why big data is famous. Okay, so they have given some thing very difficult, something like that. Let me. Okay, so let me go to the next. See, already I spoke about this yesterday only. Different what to say. 4 V's of big data. Volume, huge volume. Okay, which is not able to fit in data warehouse. See, even in data warehouse, like we don't try to fit all the data. I told right, even in big data, we do all the processing because processing is important for all the data. Because processing after that, machine learning will take our process data, reporting team will take. There are few data which people don't need. We remove that and we keep in a separate place, and which people need, and in that some data is required by CEO and all. That only we put in data warehouse. It depends on project to project. There is nothing like a hard rule like this only we have to do. Everything depends on the business logic, business rules. What some Bank of America or some SBI bank says that they don't want this data, we will not even consider it. They want only 4 data to be put in data warehouse and process all the data. There are 1000 files, process all the 1000 files, only put 100 files in the data warehouse. We will do it because business, that's all. What business was, we will do. There is no hard rule that no, we should do like this only. So already you know volume. This is why big data came. Volume, veracity, velocity, variety of data and all. So you know, scalable. Big data is highly scalable. What do you mean by scalable? I had told you on the day one also, like there are 2 kind of computing. Even supercomputer has failed in front of big data. Okay, I don't know. Some 5 or I think 2009 or 2010, they just tested big data with supercomputer. Big data versus supercomputer. You know, once upon a time, supercomputer means super, ultimate, nothing can beat. So big data, what to say, defeated, I can say. I don't know, it's a very big word. Big data defeated supercomputers. That is where all the company after 2010 started looking for 2010 or 2012 started looking and or betting. Betting means their project started going with big datas. I know like 2013, 14, 16, I was hearing most of the big data projects were getting failed because at that time they were using Hadoop and no one knew in the market, no one knew Hadoop, how it works and all, and it was very complex. Working in big data was very complex because there were a lot of server issues, lot of data was breaking and going to different servers. But while summing up, we were losing some data. No one knew which server went, and we were want to meet the infrastructure team who maintain the data server, and they were not knowing. It was very hard path, and it was told even at 2015-16. Okay, so I remember most of the Hadoop projects are getting failed. Okay, so I have heard from many of the VPs and all. So that is where slowly AWS started coming. Okay, so but now I was speaking about big data and supercomputer. See, big data behind concept. See how big data is developed. How supercomputer. If you remember, I taught you on the day one only. There is a vertical scaling and horizontal scaling. Okay, big data works on horizontal scaling. Horizontal scaling. Horizontal scaling, again it gets distributed. Supercomputers works on vertical scaling. I will give the same example what I gave on the day one. I remember this example. Okay, so in your laptop, if you have 4 GB RAM, you want to upgrade. You upgrade to 8 GB RAM because you got more data, more information, or software, whatever today you are using is not okay with 4 GB. So you change that. Maybe you change some motherboard and all, doing all the drama, everything. Spending lot of money where you would have got one more laptop, spending another 15,000, you have done. After 8 GB, higher mother processor, all those things. Now 8 GB is not also sufficient because of the new software, new data, everything. So you came to 16 GB. Okay, and also processors you increased. After that you came to 32 GB. Now that is the maximum of your laptop. It can't go. It is not expandable after that. So your supercomputer exactly works like that. It is a vertical scaling. You put more hardware to that system, there is a limit, and after that you can't do that. That means it is like I can also say I am a owner of the company, and I am very super in coding and all. I am a CEO and also coder. I can single-handedly I can complete the project. One project I completed. I got second project. Still I was able to do. I got third project. Still I was able to do. I decreased my sleeping hours. I was sleeping 8 hours. So by second project I started sleeping for 7 hours. Third project 6 hours. After that I got another fourth project, fifth project. I was doing myself. I was sleeping only 2 hours by this time. Still I was able to complete. After that, can I do it? I will die, or what happens? I will break. So this is a limitation. There is a limitation for vertical scaling. There is a maximum limitation for vertical scaling. But horizontal scaling is not like that. It is like you start a company. You are the owner. You are very smart. You come to know I am a very good coder, but I am the owner of the company. If I start coding, what will happen? My efficiency, I can't scale up. Scale up means if I get 5 or 10 projects, it becomes impossible for me to do. Maybe today I can do 1 project, 2 project, 3 project, but after that I will not happen. I'll just keep the people to work. I'll keep one employee. Assume it's a small project. I'll assign him one project. Tomorrow I got one more project. I put the second employee on the second project. Okay. I just keep the information like the metadata information. That means employee number, like your roll number. I have given one project. 2 is given the project number 2. Some code will be there. 3 is given project number 3. Only this information I'll remember, and I'll know the projects are done by my employee. Tomorrow, like third project is given to the third employee and he runs away. At that time, I might give some work to the second employee. Meanwhile, I'll be searching for a new person to hire. So this becomes vertical scaling. That means I will be bringing new systems. Like I have one laptop which has only 2 GB RAM. Now I need to increase. I'll bring one more laptop which has 2 GB RAM. These are very cheap, not very costly. I don't bring like supercomputer like 1000 GB RAM. I'll put some data here. I bring the third laptop and I'll put as 3 GB RAM. And also look here, the way it works is different. In normal thing, so there will be not like this distribution. Only single thing will be doing a complete task. Here, if you have, yesterday we saw, my name is Mahesh. So this single data would be broken. My would be given to first laptop. Like yesterday we saw MapReduce, the same way. Name will be given to the second laptop. Ease is given to one more laptop. And again I will have fourth laptop where Mahesh is given. Okay, Mahesh is given. So what it does is smartly it calculates. Here it's a name. There might be some calculation, mathematical calculation. And there might be crores of data. Don't think only 4 letter. What is the use of laptop? It's just for example. There will be billions of data, trillions of data. We have already run through all the PPTs. Like what is that? So much data is given, and finally at the end it gives the final result, whatever computation it does. So which is smarter? You can only tell whether supercomputer or big data is smarter. You are getting right, everyone? Everyone are understanding, not getting? Let me drink water. Actually, coding classes are comfortable to me. It doesn't require only speaking. 1 second, I'm drinking water. After 15 minutes, I'll take a tea break. You are getting this right. All these are a very important funda. Okay, so know this. All these are theory. Anyone can read and understand. If you are able to do the Python coding and all, this is not a difficult. It's a merry reading and understanding. Okay, you read, you will understand. The more you read, the more you understand, and it's good. You get a knowledge. Okay, you get an idea. No one will ask you to configure like this system and all. Those are done by other people. Even I don't know how that configure. Everything happens, but you should know. Why you should know? There are sometimes root cause analysis we have to do. Sometimes there will be a bottleneck. Some query or something would have crashed, or it will be taking 2-3 hours. Now I want to make it within 1 hour. That time I have to think what is happening internally, where it is blocking. Maybe it is going to all the partitions. Some partitions, I have seen this kind of example a lot. Like I have given 10 partition. 10 partition means you take 10 laptop. One partition, the more data has gone. That is called as data skewness. Remaining partition, less data has gone. Now I want to think how to redistribute that data. There is a keyword called repartitioning. So many things we can do. If I don't understand all these concepts, I can't think like that. Okay. Okay, let us. Okay, so yeah, scalability. You came to know the keyword of scalability. Only for this I explained so much. Here, scalable means you can keep on scalable. So you can increase. It's very easy to increase. But in this, it's very difficult to increase, because assume like your laptop. But you can extend your laptop, one more laptop, and connect to network and make it as 2 laptops. But in the same laptop, changing the hardware is always difficult. That's what. Cloud computing. See, there was a drawback of this Hadoop. I just told you. Like it was on-premise. On-premise means in your local. Data server was in your company, and there were many times data loss was happening. Performance issue was happening. Lot of JVM, cache. There were a lot of trouble. I have faced it. It's like more than coding, we were facing this kind of problems. So that's why cloud computing came, where entire infra thing, I need not to worry about infrastructure only. I concentrate only on my coding, those kind of things. So cloud computing became big. Data storage. there is a unlimited data storage. You want to store 1 GB, you pay for 1 GB. You want to store 1 zettabyte of data or crores of zettabyte of data, the clouding can increase within a minute. So that it can give so much data for you, but they will charge. Nothing is free in the cloud. Data analytic querying, data processing, data flow, that is what we will be doing. Okay, so big data on AWS. See, all these are the services we will be learning. Not all these services, there are different services. Kinesis we will be learning, S3 we will be learning, Glacier we will be learning, DynamoDB we will be learning, RDS we will be learning, EMR we will be learning, EC2, Redshift. These are our data engineering tools. Okay, means we collect the data, we store the data. Not only store, we do the transformation, that means process the data and it is sent for analyze. Analyze means we push to the Redshift database and from there the reporting or some people do the analysis. That is what different services are there. We will be seeing this practically. This is not the point to explain. These are called services. Amazon S3 is like your folder where you store the data file. This is a very important and common activity which I will be teaching. See, this is a NoSQL. DynamoDB, what you are seeing. Redshift is a SQL. This is a NoSQL. There is its own significance, importance of NoSQL. Okay, it is good for HTTP data, like from your API gateway, means from the websites and all you get the data, right? DynamoDB is the best. Okay, and also it is schemaless, means till now you are seeing the schema, right? Whatever, what to say, your schema means what? Rows, columns, column name. These are schemaless. It does not have a schema predefined. That means one row can have 2 columns, next row can have 5 columns. So it can keep on changing. Like you don't have a proper schema because you don't know what kind of data every day you get. You will get a new kind of data every day. So you can fit in DynamoDB. We will see that. So these are the drawbacks of data warehouse. See, all these things we can't do in data warehouse. Today, most of the data are like crazily coming. You don't know. You get from website, you get from there, that and all. And Kinesis are for real-time data. I told, right, Uber, Ola example, where you get on the fly and you have to analyze on the fly and give the output on the fly. Means within 5 minutes, 10 minutes you need to do. These are not possible with data warehouse, traditional data warehouse. DynamoDB, NoSQL is not possible with data warehouse. These are massively parallel columnar data processing. Even our data warehouse are row oriented. This is very fast. This is also not possible from data warehouse. That's what AWS means. Cloud became a very big data, basically big data. Big data had all these features. Hadoop also. Now cloud has more features. Okay. Scalability on AWS. Here, good thing. I didn't know like they have given the same thing. I am also seeing the PPT. See here, vertical scalability, horizontal scalability. Just now I told. See here, less CPU, RAM. Horizontal scalability, more. I don't know what is this less machine. More machines and all it has to come. Okay. Just stick on to what I told you. Auto scalable by CPU, memory, network. See here, it can scale. CPU, memory, network, everything. This is again, they tell pay as you go, but as a company you will be running your system 24/7. That means you have to pay always. They tell 1 hour you work and you stop, after that you need not to pay. So no company will do like that. You will be running entire year, entire month and all. You can't ask, you go to the ATM and you call the bank and bank will tell now it is night 10 o'clock, we have switched off our cloud server because it is very costly. Come tomorrow and take your money. Or Amazon will tell Amazon or Flipkart, now it is night 10 o'clock, morning at 8 o'clock we will switch on the server. You start booking or ordering. So it's not possible. 24/7 you have to do. That means money will go crazily. If you don't build your architecture properly in AWS, I told yesterday, right, there was one meme that he was very rich person. He just switched on the EC2 and he asked how you became beggar, you look rich. he told I had switched on the EC2 and forgot to stop it. That means he forgot to stop it, and his EC2 was running. And for you also, when I am teaching AWS, I will teach you how to delete the service on the day only. Don't forget to do, because one of my junior had got 2 lakh bill. Okay, I don't know whether he had that much money. He forgot. He was running some high-end cluster and forgot to switch off. In a month he got 2 lakh. Okay, you will not even have. So this is little bit tricky. So I suggest to delete, and you need not to overdo the program. So that's what I told. Smartly, if you are able to theoretically explain most of the things, so it is also possible. There are some things where you have to practice, like Python coding. There are some things smartly you can speak. I will showcase how to do. Maybe you want to try once, and try to pick up presenting that to the interview. How will happen, what will happen, and all. Okay. Basically, some of the things you become strong only once you are in the project only. That is sad to say, but that is true. Okay. So, okay. But yeah, I am cautioning you now only. I will caution when I start. Anything we do in the AWS, you have to stop it. And also when you open the AWS account, they will ask for all your your debit card or credit card and all. You should plan to keep it handy by January, because if you want to practice, you should have debit and credit card and all. I think debit also will work, because you will also incur some 1,000 or 2,000 rupees charges, because some of the services might not be free. There will be a small charges, means it will be in dollar. So if it is $4, $5 means 500, 600 rupees will go. So that we will speak later, but just to I think everyone will have some debit or credit card. Just you should be very cautious when we are working on AWS, because it will cost. It's not free. You see, for learning only it is not free. How about like if you are in the company? I see some as free tier, but again it will charge. Maybe 15-20 days or 1 month it will be free. Okay, alright. So we saw this. Cloud computing on AWS. 1 second. Rich service, pay as you go, cloud computing, EC2, all these are services which we will be learning. DynamoDB. Data store on AWS. To store data in AWS, it is S3. S3 is the service we use. Okay, S3 is commonly used, and we will learn it. And Glacier also will use, we will learn it. The same thing they have given, secure, durable, highly available. We call that as not folder, we call it as buckets. Okay, the S3s are called as bucket, means one folder. We don't call it as folder. S3 is the name given to the folder, but in AWS we call S3 as a bucket. In a bucket, we create one bucket. Maybe I want to store some old data. I create a bucket and give the name as old. We will see that. And we don't call everything is an object. Basically, what I told folder is a wrong thing. In AWS, everything internally is stored as object. Like S3 is one object, bucket is one object. Okay, but for your understanding, you can think as a folder only. Uniquely stored entities, uniquely within the buckets by the name and version ID, support versioning. So it supports versioning. What is versioning means? By accidentally you delete some data in the S3. You need not to worry. There is a version. Means the old data, date when you deleted, you can restore. Like the same thing, right? You have some file. You accidentally delete this file. It would be in recycle bin. You can get it back, restore. Something like that. Versioning will be there. Consistent models, updates, all those things. So Glacier is for storing old data. Like it's a backup data. That's what archival data. Means what happens? Data would be very huge. After 3-4 months of your analysis, you don't require that data. What you will do, you keep in a backup. Why you keep in backup? It is cheaper than the S3. S3, if it is like 5 rupees, Glacier will be 1 or 2 rupees. So obviously, it's all about money when you come to cloud. So you keep in a backup. You can keep in S3 also, but it is costly. So that's why we keep in Glacier. Okay, you can also encrypt the data. Encrypt means it will get into like binary format where no one is readable. There are some KMS algorithm where I'll show that. Okay, see, that's what they have told. 4x time cheaper than S3. S3 data can be archived into Glacier by lifecycle rules. You will see that 4x time cheaper than the S3. See here, there is SQL in AWS, no SQL by DynamoDB. Text search and all comes to the data science. We are not worried. DynamoDB, Redshift, RDS, we will be learning. Okay, so all these are just QuickSight and all is for reporting. That is not a part of our thing. See, DynamoDB, how the data gets stored, key value. Already you know key value, dictionary data. So DynamoDB will also have dictionary kind of data. Now, because of reading in Python dictionary, you can easily visualize how the dictionary data will be there. Eventually consistent, strong. It has some indexes, secondary and primary index and all. That I will, when I start AWS, I will just go through that. Redshift is against here data warehouse solution. You can't think as soon as big data come, there is no data warehouse. That is what I was telling. Now also, even in big data, even in AWS, we do data warehouse. Endpoint is data warehouse. But the problem is like we would have got like thousands of TB, maybe 100 TB only we put in data warehouse. And it takes some time to do in data warehouse, because in Redshift I have to write the tables, build the schema, give foreign key, primary key, lot of things will happen. It will take good amount of time. But my processing will already be done with Spark. Already with PySpark I would have done all the analysis, transformation, reports, everything. Later for a long run, like because PySpark and all, not every person, you should be a tech savvy to do. See, you are only learning from couple of months being an engineer. So how about they would have done some finance, there would be some finance person. You want to know like how much in the company the cost is happening, the owner. He will get in this database by running SQL thing. If he doesn't keep in SQL, if he keeps in data lake, we can't tell, write a PySpark. Then he has to learn PySpark. So Narayan Murthy, I have to tell, learn PySpark and do. I can tell Narayan Murthy or a person under him, maybe is whatever CTO or someone, to write a query. I will not tell, he will know that. Okay. RDS, I can't explain this. See, same thing. You have a relational database, right? What is relational database? Oracle, SQL Server and all. So I can host this in the cloud. Means you downloaded and installed Oracle in your local. There are a lot of problems keeping in local. If I want to increase the cluster size, I can't do that. And something down goes down, it is gone. For you it is okay, but if some project or bank application is hosting there, if bank application goes down, you are doing some transaction of 5 lakh, immediately it stops. Will you be happy? Very angry. That's why they have kept your relational database also in the cloud by the name RDS. RDS means relational data store. I will teach you how to create an RDS and host, connect from the local. This is also there. Okay, all these are there in the part of our curriculum. So Elasticsearch we don't do. This is not required. Cloud search is not required. QuickSight is not required. Data processing on AWS. Yeah, this is one good point which I want to tell. So let us take a small tea break. So maybe 5 or 5 I'll come. I am going outside for tea to the hotel. So maybe 15 or 20 minutes it will take. So we will get back. Okay. 5 or 5. Okay, thank you. Hello. Okay. All right. Let us continue. Okay. Okay. So yeah. So data processing on AWS. So we saw uh, basically huge amount of data. That's why we are doing, and it's distributed. By this time, you should know what is the meaning of distributed, scalable. Distributed means one data will not go in a single line. One data gets broken, distributed to different engines, different system, and data gets processes. So because of this, big data has become very powerful. Okay. So it's a our Spark is a distributed processing engine. That's all. Pandas is not a distributed processing engine. It will give you the data frame like rows and columns, which is very useful for an ETL or a data engineer. But the amount of data is more. Pandas can't handle. We need a Spark to do it, and it supports batch, stream. So there is a concept I need to speak about this. This is an important concept. So batch, stream, under batch we have full load and what to say, partial load or an incremental load. So let me explain you that. Important. All these are important. Know this. See, basically, what do you mean by batch? Forget about stream now. So batch means today, for example, yeah, today you have loaded the data. Assume like yeah, today data is loaded of which days? Like today's data is loaded tomorrow. That means today was morning 9 to night 9 a.m. to 9 p.m. The business transaction happens. After 12 a.m. in the night, midnight, 12 a.m. in the midnight, you will have build ETL pipelines. That is what you do. Your job is to build ETL pipelines, ETL pipeline to get the data from the source. We already saw so many examples. It's almost the same architecture. Whatever I show data warehouse, there you saw source as a database. Here we might get data from SFTP, from any app, all those things. So you build a ETL pipeline using big data, AWS, some services. This will pull all the data and load to the whatever, load to S3 bucket, or you want to put it to the Redshift, also fine. For your understanding, put into the Redshift only, load to S3 bucket and Redshift data warehouse. Okay, so this kind of activity is batch loading. Batch loading. What do you mean by batch loading? It goes in a batch. Like it completes a day. In the night, it will have a lot of pipelines. There can be like 40 pipelines, 50 pipelines, or even 100 pipelines, data pipelines. So you would have done data pipelines means like, yeah, you would have one of the pipeline would be getting some source data. You will be doing filtering source data and you will be doing filter and loading to Redshift. One more pipeline, you are getting source data, you are doing some joins and loading to Redshift. So this becomes one data pipeline. You know, filtering, joining and all in SQL. Something like that we will be doing in PySpark also. Okay, this becomes one more data pipeline. So like this you have 50 to 100 data pipelines. So directly it can't load to the data warehouse. All these are called transformation. That means you are transforming the data. Maybe you need only department number 20 and you need some department and employee data. You are joining, you are doing some other activity. So this is a batch loading. You are not loading live. That becomes a stream loading. Stream loading you saw, right? One more. Stream loading means the Uber example I gave you, right? Uber or Ola example, where you need to understand the traffic right now. There is no point I get the data tomorrow. Tomorrow, next day, if today is, what is today? 10th December. 10th December 2023 data, managers will get from the data warehouse reporting on 11th December 2023. See, 1 day gap. Uber, Ola, they want to increase the price based on the traffic. Is this useful for them? You get the data from 9 a.m. to 9 p.m. Can Friday traffic can be same as Saturday traffic? No. Monday traffic will not be same as Tuesday traffic. So there is no use of doing batch loading for Ola, Uber and all, because they have a different use cases. They need to increase the price based on that movement. Now at 9:30 I want to see traffic is not so much, price minus 50 rupees less, 300 rupees from source to destination. At 10 o'clock traffic is very much high, and also cabs are not getting so frequently, a lot of bookings, so make it 350 or 375 rupees. So how they come to know? Because of stream loading. In stream loading, what they do is, data comes from source, they use some even kinesis, which I'll be showing you. Kinesis, it tries to analyze and move to whatever reports or DynamoDB, wherever it is. So this is a real time data. You can take as stream data as also real time data. So all this is possible with AWS or big data. That's what. And also under batch we have two kind of loading. This is also I want to say. So you came to know right now about batch load and stream load. In batch load there are two types of load. One is full loading and second one is incremental loading. Full load means business has started from 5 years. There was no data warehouse or OLTP system. First time you want to load all the 5-year data, like 2000, assume like 2018 till 2023 December 10th or December 5th you want to load all, or December 9th you want to load all the data. So this is full loading. It takes lot of time. Immediately you can't load like that. They break it month on month and load to the data warehouse. In incremental loading, after 9th, 10th come, 11th come. So they just don't want to load all the data. They just load 1 day data. For example, if today is 11th, they load only 10th data. Based on the business requirement, it can be 15 days data. They didn't load for 10 days. After 10 days, they want last 10 days data. Anyway, but full load means everything from the beginning till the current. Incremental load means after this, there is no point of loading from 2018. From 2018, already data is there. 2018 till 2023, December 9th, already data is there in the data warehouse. Now, days will go on like 10th, 11th, 12th and all. So now in the incremental load, you just load 2023 December 10th data on 11th. You saw right, on 11th, 10th data is loaded. When it becomes 12th, 11th data you will load. So this is a incremental loading. Okay, this is a batch. Under batch you have full load and incremental loading. Any data warehouse you start, you first time what you do a full load. After that you just do incremental load. Okay, these concepts I want you guys to understand. So EMR, see here kinesis. Kinesis is for real time data. Machine learning anyhow we are not working. Okay, so see what happens. EMR is elastic map reduce. This is good for getting even the Hadoop infrastructure. Means you need to run some Hadoop thing like Hive or HBase and all. You can use EMR. That means your AWS has a capacity even to run the Hadoop services. Even Spark is a part of Hadoop. Spark came from Hadoop. Okay, Spark is not a part of AWS. Don't misunderstand. So Spark was under Hadoop. So we use that. Even what to say? Even if I use IVE here, I can use in EMR. So that's what. And also there are other things which they have told here. Just it's a high level. I don't want to. Yeah, see, this is the architecture of EMR. It will have, see, I told right, as soon as big data comes, it will have one master node. 1 minute, I am getting a call. Hello. ಹೇಳ. ನಾಳೆ ಹೋಗ್ತಿದ್ದೀರಾ? ನಾಳೆ ಲಾಸ್ಟ್ ಕಾರ್ತಿಕನ ಇಷ್ಟೊತ್ತಿಗೆ ಹೋಗ್ತಿದ್ದೀರಾ? ನೋಡ್ತೀನಿ ತಡಿ, ಕಾಲ್ ಮಾಡ್ತೀನಿ ನಿನಗೆ. ಬರೋದು ಸರಿ, ಓಕೆ. Okay, all right. So see, as soon as big data comes, there will be lot of nodes, means lot of thing, like one would be manager. I just showed you here, same thing. They have given more technical, so you understand this. Like supercomputer, there will be one thing, owner. You will just keep the metadata information. This you can think as master node, means it keeps only metadata information, like for which person, which employee I gave which project, which employee I gave which project. Like this, there are lot of slave nodes. Slave nodes means you can think as employee. Master node means you can think as owner. Owner duty is not to do project. Owner duty is to check which project is given to which person and whether he is doing properly. This person will send the acknowledgement. So that is what, in a simple way. See, if you want more power, what you do? You get more employee. The same way, even in EMR, even in EC2 and all, I can start increasing the slave node. Slave node means the more computer. So here it is 4. If I want 50, I can increase 50. Okay, there is one master node. Maybe there might be some secondary master node as a backup. Don't worry about that. But master node will keep only the information of which person is doing what activity, he is acknowledging properly. That means he is properly working or not. If he is not working, maybe it is die. So he will give that task here. Okay, or he will increase. So you can manually increase. I want 20 slave nodes. You will get 20. That is what. See here, master node tracks, monitors and manages the cluster. Same concept. What if I have told in a layman term here, the same thing they are trying to speak more technically. Monitors manage the cluster. Don't worry about all this resource manager, then it is again a new topic. Okay, this is all Hadoop and resource manager and all. Okay, core node, slave node runs task and stores data in HDFS. See, HDFS is again Hadoop file system. Okay, because EMR is a part of HD, means Hadoop thing. In AWS there is service called EMR. Whenever you want to run Hadoop thing, you can use it. That's why it is HDFS and all. Only runs the task here. Task node. Okay, maybe yeah, inside the slave node there is something called task node. Only runs the task. That is what they have told. EMR best practices. Okay, on demand, spot is there. There is something like on demand and spot. Okay, this is not required. Every single thing, life cycle, it's okay. This also not required. Storage, see, basically it stores in Hadoop file system. That's what I told. EMR, we have one services in AWS to work on Hadoop activity. If I am still planning to show you, I don't know, based on whether I want to show or not, I will show one practical example. Okay, so this PPT is depicting more of EMR, because sometimes in interview they will ask question or difference between EMR and glue, all those things. See, distributed scalable file system for Hadoop stores multiple copies to prevent data loss on failure. See, always in the our big data, one copy would not be there. There will be the same data 4-5 copies. If 1 or 2 get lost, you have another 2-3 copies. So that means there will be no loss of data. Used by master core nodes. See here, used for intermediate result during map produce processing. Yesterday I told you about map and reduce, how it works. So now you should be smart enough to pick up the keywords and understand, okay, map reduce means it splits the data and merges the data. Okay, that is how map reduce works. So this is what like I am expecting, because over a night I teach and you don't understand. It takes over the period of time to know this. I also took couple of what, at least one, I have worked on it, like I have worked on this project so I can visualize easily, but you have not worked on the project. It's very difficult for me to understand, for me to make you understand the way I want you to understand. It's difficult, I know, because I have worked on this. I can visualize, you might not be able to visualize, but I am telling about all the information. I don't want to miss these informations, because yeah, it's good to know more. And also like you have that, somewhere you have that idea, these are all there. Okay, these are all there. So maybe like, maybe in some interview they ask, okay sir, I had done that, let me revisit it. Okay, usually for you guys it would be simple only. They'll ask Python, Spark some questions, cloud, SQL, some theoretical questions. That's all they will ask. But yeah, prepare for the worst. That is always the funda. Prepare worst, and it is not only for your interview. For all these things becomes very important when you are working in the company. Means lot of things starts happening in the project. So you should know all these things. That is my intention, not for only interview. Okay, I want to concentrate on two things. One is on interview perspective, one is for working perspective. Apart from that, I am not interested on theoretical thing. Like there are lot of things which I don't want to do, because I am not a trainer who studies the book and does. I know like what is there in the company and what has to be taught. Okay, that is the only thing. I am teaching this not on the perspective of interview, on the perspective of the job. Okay, when you clear the interview, okay, you are going into the job, someone speaks about EMR, someone speaks about S3 and all those things, you should not become numb. At least you should have an idea, okay, there was something on EMR, sir, I thought, let me revisit the video, let me go through some of the more information on that is the idea. But you are able to know all these things, it's quite good actually. So I don't want to go with this. This is elastic map reduce file system. It goes to the next level and all. They have spoken a lot on EMR, so I don't want to go whatever spoken to teach you. Okay, see here, EMR can do all this. It's a framework, it's a service to do your Hadoop. Hadoop, any of it is deprecated, means not deprecated, not many people are using, but see, Spark is also part of Hadoop. I can do Spark. One of the project I've used EMR to do Spark. Okay, there is, I can do Hive, I can use HBase. All these are a part of Hadoop, not the part of AWS. But yeah, in this, Spark has become very popular. It is used in AWS, Google Cloud. It is used in Microsoft Azure, everywhere. Okay, because when it came, Spark was not popular. Before Spark they were using Hive, other things. Spark slowly became famous and became very strong, and they others did not wanted to use any other thing apart from Spark, because they came to know the importance. Because Spark works with a RAM concept, Hadoop works with a storage concept. Always, you know, Spark's RAM is faster than the storage, so that's why Spark outsmart other thing. Kinesis we will be learning. It's a real-time data. I just told you, collects and process large streams means real-time data in real time. I already gave you an example and importance of the real time, like Uber, Ola. There are many projects like that where they need to take decision immediately. They want to increase or decrease the price based on the demand. So that is a common scenario today. Synchronous replicating streaming data, it comes with some messaging queue concept. Okay, not so elastic by there is a shard and partition concept in Kinesis. I will go to that. When I do that, I have a separate PPT for Kinesis. I will explain you that. See, that is what like many times in the interview they expect. Kinesis, what does Kinesis does? Can you explain the architecture of Kinesis? This is how smartly I am trying to say Even if you don't practice too much on AWS also, if you are good at speaking and knowing the architecture, knowing when to use what, you are done with the job. Okay, that is what they will ask. Kinesis, you don't understand what is a use. It doesn't matter. Kinesis, you need to know why Kinesis is used for real-time data and how the Kinesis architecture is there. Can you see your shards and all? I'll teach you. The data gets into partition, they call it as shards, and 1 MB data goes, and in 60 seconds the data gets replicated. Like this, if you start speaking, you are done with Kinesis. That's all. Okay, that is what I am trying to make you think. It's not about doing on AWS and all. It's about how you present, how you present, and how you know the knowledge, how you know the information. That matters a lot. Okay, so it's not as Python you need not to speak. It's only about coding. SQL is about coding. Spark is mixture of coding and this. When cloud comes, there is nothing to code. It's about the way you speak, the way you present, because it's a UI. Okay, all right. So also integrated with Spark. See, from Kinesis real-time data comes. In Spark they do analysis in minutes or 5-10 minutes and send the report. That is also possible. High level architecture. This is what I was trying to say. So the data gets divided into shards. They also call this as partitions. And from here it can move to anywhere. Like S3 bucket you can put DynamoDB or Redshift. So many things you can do. How you get the data? Live data you might get from mobile, some EC2, all those things you can do. Yeah, EC2 also I want to speak. EC2 is like your machine, that's all. Elastic compute. It's like your laptop. Okay. In the AWS, I will show you this. I will show you this. In AWS, you can have one OS. You can create one OS. After creating a OS, you can install the software and you can do all processing. That's what AWS also gives. They call it as EC2 instance. You have different kind of configuration, from a smaller to a very bigger configuration operating system. You have all kind of operating system, Linux, Windows, Mac, Macintosh. There are different kinds of operating system that comes under EC2. EC2 is gives you a machine like your laptop, means the OS, all the configuration, everything, where you can install the software. Like your laptop you can work, but it charges. It is a money. There is some free tier also. Okay, that's why they have given EC2 instance. Here also some company would have installed their application or a website, and data comes from here also to your so whatever the Kinesis. Kinesis key concepts. That's what, all data stored for 28 hours. It can also be increased. Usually we call it as shards. Group of data records. Kinesis streams are scaled. Provides 1 MB per second data, and see, it takes data 1 MB per second, and output data can be 2 MB per second. Okay, that means 2-3 source you are getting data 1 MB 1 MB. Output at a second it can send 2 MB of data. Okay, that's what they are telling. Maybe these kind of things they will ask. How much data as an input Kinesis can take? 1 MB. How much data Kinesis can give as an output? Kinesis can be what kind of data format it can be. You can convert the Kinesis data to Parquet, ORC, all those data formats. What is the data stored in the Kinesis? It can be 24 hours to 7 days. The data can be stored. After that it goes off. Like this question starts coming more in AWS. Can you tell me one architecture how you are able to get this data? So we through the mobile client, the data was moving to the Kinesis through a shards. Shards was taking 1 MB as an input, and from there the data was moved to S3 bucket. So 2 MB per second data was returned to the S3 bucket. See here, if you are able to tell like this, it's good. Okay, for a fresher and all, they don't expect more than that. For us, they expect a lot of questions. That's what, I don't want to speak all those things, then you will get confused. So that's all you have to speak. They will be very happy. Okay, this one. Same thing, partition key also is there. Group data by shard used to determine which shard a given data record belongs to. See, there will be some partition key like 1, 2, 3 and all. So it will help you to understand what data my is in which shard. Okay, they will also have sequence number for the shard like 1, 2, 3, 4. Okay, let us see whether we have an architecture of marking. Okay. Okay, getting data in. See here, producer means the application which produce the data. See here, shard 1, shard 2, shard 3, shard 3, like this it will be there. Producer use put. We will see practically. There is some put operation. Put means you are putting the data in the stream. A partition key is used to distribute the put across the shards. Across the shard, data is put 1 MB, 1 MB. NUQ sequence number. For everything they would have given for a shard, there is a sequence number. Okay, that is what they are trying to say. Getting out. Getting out, here they have taken EC2, you can take it as S3 bucket. The data goes like this. Oh, lambda. Okay, should I speak about lambda right now? You'll understand. Okay, data flow on AWS. Okay, Firehouse. See, again it's a part of Kinesis only. Okay, but it is not mainly a real time. It can be a batch data, means it can move the data to S3 or Redshift. It takes some time, buffering time it takes. Okay. After that, data pipeline. Okay, data migration service. This is what DMS, data migration service. See, you have a local Oracle RDS. I spoke already. You have a database. What to say, in a local Oracle database. Now you want to move that to the Amazon Web Services. You can do same. Oracle can be hosted in the cloud. That is possible using data migration services. See here, Oracle to Oracle. Oracle to Oracle you can do. Oracle you want to host Postgres, you want to keep in AWS. That also you can do it. Okay. I can explain better this one. See, you have installed in your local Oracle, right? Now the same database, this is a Oracle. This is in your laptop or local server, whatever you can think. Now there is a AWS. This is a AWS. I can create in AWS the Oracle. Okay, and bring all this data. Bring all this data means bring all this Oracle data, whatever you have tables, into the AWS Oracle. Why AWS Oracle? It would be very fast, no downtime. You can increase the storage, you can increase the speed, which is not possible in your local, because local becomes vertical scaling. AWS becomes horizontal scaling. Internally it starts increasing the space, RAM, memory. So everyone today, even if you are working on Postgres, Oracle, relational database, they host in the cloud, basically cloud. For our course, you can think it as AWS. That is what. Okay, you can also, this is one scenario. You have Oracle in the source. Now instead of Oracle, you want to what? Instead of Oracle, you want to keep all the data in the Postgres. You can do that. Heterogeneous moving of data. This is Postgres. This is also possible. That time you have to convert some data types and all, because Oracle database data types would not be equal to Postgres. There will be some conversion which is happening in between. Okay. There will be conversion of data type, conversions of data types. It would not be same in both the things. Some small changes will happen. That's what they are. This complete thing is told. Database migration service, heterogeneous migration, homogeneous, heterogeneous. Snowball is not required. Demo time, steps to demo also they have done. Okay, it's okay. Okay, I think yeah, this and all. I think lot of information. I can't do Spark right now, so it has to start with a fresh mind. If I just bump in Spark, you will not understand anything because lot of information. I know that. 1 minute. Can I share here the big data and your computer? Okay, downloads. Data warehouse, big data. 1, 2, 3. Can it go? Or it because of this? Then I have to upload. Okay. Your computer, data warehouse. Okay, I'm sending here so that it should not be lag, so you can also go through that. And I will have big data. Is there something is missing? Big data on AWS. So big data 1, 2, 4. 1, 2, 3, 4. Please share the attendance sheet. Okay. Yeah, these things you should know because without a theory, all this information you can't work. That is a thing. Like you should know all these are the things, concepts. Oh, okay. Attendance I will share from. Can anyone share the attendance? I am using a new laptop. I don't see the attendance here. I have to again copy from there. Someone share the attendance here only. It's in one more laptop. Wait, let me see in the. Any doubt in today's class? I will share. Wait, I am just switching on my laptop. Give me a minute. I'll share the attendance also. Any doubt? Are you able to get? Okay, great. So attendance is shared. You can do it. So please know all those things. Okay. I have done less content only couple of times. If you see big data, data warehouse, same content I just revisited. The reason is so you understand strongly with different examples. Okay. Know what is OLTP, OLAP, data warehouse, data modeling, star schema, snowflake schema, what is big data, horizontal scaling, vertical scaling, and all these things like different services, just high level. But we will be doing those practically, nothing to worry. But yeah, know all the things whatever we have done because it is really helpful for you. Okay, we will meet next week. Okay, so you just see all these things and please install the PySpark. That is important. Please install PySpark software. I don't have access. You just check with Neha. So everyone requests the access. They might give you the access. Or else call her tomorrow and try to take it. Okay, then we will meet next week. Thank you. Any doubt, email me. Okay.